Okay, there we go. Hello and welcome to Component Rescue Component Level Logic Board Repair. My name is Harrison and today we will be working on I believe this is a 2010 MacBook from one of the white polycarbonate ones. So the issue with this board is that whenever you plug a charger in, nothing happens. And the board won't power on at all, it won't charge, and there's no light on the charger. So, let's see. So right here, let's just kind of look over this board and see if maybe we can see why it's not working. I already kind of looked it over and I didn't see any actual liquid damage on it. So we're just going to do an inspection a little closer to see if we can find any issues. So this chip right here is going to be the charging chip and the one that controls PP-Bus G3 Hot. And I don't know if you guys can see, but some of these contacts don't look the greatest, but most of them still do look. That one right there might need to be fixed, but a lot of these look like they're still fine. So that's one place I definitely want to take a look at since we're not getting a light. The other place we definitely want to look at is up here. Let me get this back in focus. Up here where some of the charging circuitry is that deals with the DCM board. Oh, look, there we go right there. I'm guessing, let me get this in focus for you guys. I'm guessing this little resistor right here is probably going to have something to do with why this isn't coming on, since there's a hole burned in the middle of it. So why is my board view not coming up? Let's try closing it out and reopening it. Do we have it now? Hey, there we go. Okay. So that's going to be this resistor right here. Which this resistor is going to take, looks like this is for the power in from the charger. So this right here, this power signal on my mouse isn't in the right place. But the one that's clicked on right now, that power signal comes from this fuse over here, which goes directly to the DCM board. So if I click there, it'll go directly to the DCM board right over here. So it looks like this resistor got blown, and that could be from a few reasons. One of them could be that something just normally caused it to blow. There was a surge of power, and that just took the brunt of the damage. Or the other option is that there could be a short somewhere on that power rail. So I'm going to go ahead and pull my multimeter out, and we will test this to see if there's a short to ground. There we go. I'm going to put that on ground. I'll stick that right there. And it doesn't look like we got a short to ground. So let's see if this fuse right here is still good. That fuse is still good. This is not good at all. Let's see, what are we getting? We're getting 82 ohms, and that's supposed to be a 47 ohm resistor. So that's definitely a problem. So let's see, is there any other damage on this board before I just go ahead and replace that? if there's nothing else that looks suspect, we can go ahead and replace that. And that will more than likely fix any issues that we're having. Let's see, up here, we got a tiny bit of liquid damage on these probe points. Usually this green slimy stuff usually doesn't cause too many problems, but it can sometimes. So let's see, where is this? This is right here. So it looks like those are not important because they're for SMC and EFI programming. So I think I'll just go ahead and replace that little resistor with one from a donor board I got lying over here. And we should have a working board after that. So let's get that in the frame. Let's get this nice and in focus for me, since I need to be able to see the part while I'm replacing it. Let's get my hot air turned on. And we'll add a little bit of flux. Come on. It smells wonderful. I haven't used this in quite a bit, which is also the reason I haven't been streaming much lately. It's because I have been out of town for quite some time now, actually. So I just haven't really had the chance to stream at all. But I'm back now, and I got a few boards to work on. I got this. I think I have another one of these that has no backlight. And I think I got one other one to work on now. I might stream some of those too. We'll just have to see how much free time I have. But let's go ahead and get this swapped out. Come on. Come off. Wow, that just does not want to get off of there. I may need my other set of tweezers. Let me grab them real quick. Well, I couldn't find my other set of tweezers. I may have left them when I was visiting family, since I was fixing some computers there. But I'll try and make it work with these. These aren't as great. They're more meant for picking up bigger things. But we'll see what we can do. So what I'm going to do now, since I couldn't get that off, is I'm going to try adding some leaded solder to it to make it a little bit easier to work with. So I'm waiting on my soldering iron to heat up real quick, and then we'll get that done and get that replaced. Okay, there we go. There we go, we got some. There we go. So now that we got that on there, let's try again at pulling this little thing off. Let's get it back in view. There we go. There we go, we finally got it off. And it looks like it did burn the board a little bit right there when that chip burned, but that's okay. It doesn't look too bad. So we'll go ahead and add some flux. And I'll turn this to make it a little bit easier for me to solder. And we will tin those pads and clean all the old solder off. There we go. There we go. Now that those are nice and cleaned off, we can grab a, I don't know, where'd they go? Here they are. Ah, man, everything is just a mess right now. Okay, we can grab Q-tip and clean off any gunk that's there and the old flux to give us two nice clean pads to solder off of. Okay, and now we'll add a bit of fresh flux. And we'll go ahead and tin both of those pads. Okay, so now I can kind of move this off to the side. Well, nah, actually I'll leave it there, because I'm going to need to, I'll add a bit of fresh flux to there, and then I'll grab my donor board from right here. And we'll go ahead and pull our replacement resistor off of it. There we go. Okay. Is that nice and soldered on there? That's beautiful. So, now that we got that replaced, I'll go ahead and test this just to be sure. That's all nice and dandy. There's our freshly soldered on resistor. Oh wait, or maybe this is 1 ohm. Let me see. Thought it was 47. Maybe it's not. But if this... I thought I grabbed the right board. Let's see, R6905. We're gonna edit, fine, R6905. Yeah, you guys can see that. Okay, that is indeed a 47 ohm resistor. Why does this board have a different resistor? Well, that's interesting. Okay, well, let's see if I can find a 47 ohm resistor on this or another board. I don't see one on there. Maybe there's one on this. I ought to have one somewhere. Nope. What about these? Is there one on a newer board, maybe? Let's see. Is this the right resistor? Right. 47R0. Where's the one that I took off? Here it is. Are they the same size? They are the same size. Let me check the schematic in board view on this to see if I can use that resistor. This is just one of my trash boards. I'm pulling it off. See, look, it has there's a hole burned in the board. Yay. Okay, this is a 3115. So 3115. See, which one was that? It's gonna be this one. So R6990. 6990. Here we go. Next. Here we go. Okay, so it looks like those are indeed the same component. So we'll go ahead and steal that off of this board right here. So I'll do it like this. Just kind of go in there. Okay, we got that. I'll set this board off to the side since we don't need it now. And we'll go ahead and pull off that component that we don't need. And then I'll add a bit more flux. And now we'll put the correct one on there. That's a little crooked, but it's okay. It doesn't really matter. But I feel like I need to fix it anyways, so pull out a bit of flux. And we'll reflow that back into place. There we go, just like new. Just like new. So, oh, I accidentally switched to something. There we go, we're back on the board now. We'll add me back in there too. So as you can see, I now have the correct resistor on here. As you can see, now it's the correct 47 ohm resistor, and it's soldered on there nice and straight and pushed down onto the board. So now what we're going to do is we're going to plug the MagSafe back in, and we'll plug the board in and see what we get. Maybe if we're lucky, we'll get power. Here, I'll go over here to the MagSafe so you can see the adapter. Where's my mag one? Here it is. Okay, here we go. We got it right here. Is that zoomed out all the way? Yeah. So go ahead and pop that on there. Oh no, we got a fire. That means that that resistor I just put on there probably just burned. Which means that we're going to have another issue with the computer besides just this little resistor right here. Let's take a look at this. So first of all, we'll see if that resistor is still good. 47 ohms. Okay, so that's fine. That's fine right there. And then from here, where's ground? Oh boy. I was hoping this would be an easy one. But when is anything ever easy? Okay, so the top of this capacitor right next to it is supposed to be grounded. I'll go ahead and turn hot air off for now. So what's on the bottom right there? Okay, so do we have a short? Aha, interesting. So right there, we don't have a short. However, on, let's see what the schematic says. This is PP VN G3 hot, PP3V42 G3H. On that, apparently there's a short to ground. So let's see, that's C6990. Let's see that in the schematic. C6990. Okay. So looks like there's two ways that can be shorted to ground. So let's switch over to that. So either this capacitor right here, I'm pretty sure, yeah, that goes to ground. So either this capacitor right here is shorted to ground, or this chip right here is shorted to ground, which this chip is what makes PP3V42, which is what powers the SMC along with part of the PCH. And if this voltage isn't present, we won't see any light on the charger like we didn't. So the part I just replaced is this one right here, that resistor. And there didn't appear to be a short on that side of the resistor. Let me double check though. So let's see, it's there. Okay, so there's no short on that side of the resistor. But in between the resistor and that is this diode right here. So what this diode, or let me switch over to that. I think that's it. Yeah. So this diode that's right here, it takes the input on pin 1 from the charger, and then on pin 3 it takes the input from the battery, and then it puts the output over here on this side and to power the PP3V42 generator. But the reason the diode's there is so that the power from the charger doesn't go directly to the battery, and so that the power from the battery doesn't go directly to the charger, because it would not end up good if either of those happened. So it appears that we have a short there that is keeping the computer from turning on. So, man, what did I do with that? I just had one of these. Here we go. Let's see, so is that shorted on a regular board? That is not shorted on a regular board. So that means, my guess is that it's going to be that capacitor right there. So I'll go ahead and turn my hot air on, and we'll pull that capacitor off and see if that short is still there. If it is, then we'll just have to keep going. But if the short's gone when I pull that off, I should just be able to put another capacitor on there, and we should be good to go. So I gotta let my hot air heat back up real quick. Let's get that in focus. So the capacitor I'm talking about is this one right there. Okay. Heat the board up a little bit, and we'll move in close. God, I hate these tweezers. I'm gonna have to find my good ones. Okay, there we go. We got that capacitor off. So, we're going to, oh, my multimeter shut off. There we go. So now, we'll check and see if the short is still there. Which, top is ground. So there we go. Of course, that's shorted. But the bottom one is no longer shorted. So it looks like all we'll need is a new cap right there, and then this board should hopefully be good to go, assuming nothing else is shorted. So I'm going to guess that that cap is what blew that resistor because of the amount of power that it was pulling. So we'll go ahead and tin those pads up. These pads look a lot nicer, so I don't think I'm going to need a bit more flux. I don't think I'm going to have to completely clean them off like I did the last ones. Plus, I'm just trying to get this done. Okay, We'll go over here. Oh, that's the wrong board. Here we go. I'm going to make sure this capacitor is the right value. So let's see. No, don't do this. Why? Why do you crash on me, open board view? Why do you crash? You know what? Oh well, I'll have to deal with that in a bit. It should be fine, even if it's slightly different. Usually it doesn't matter quite as much if the capacitor is slightly different. I'm not saying that you should just go around putting the wrong capacitors on there, but I'm just saying that if this is the wrong value, it's not like the computer's going to blow up or anything. And is this shorted? This one is not shorted. So we'll go ahead, pull that off, and then stick it on here, and we can be done with this. I'll do it like this. That'll be fine. Heat up the board a bit. And we'll go in and pull it off. Oh, god damn it. Why does this happen to me? Okay, well, I guess I'm gonna have to steal a resistor from something else, unless I can find another board. Which I don't think I have another one of these that doesn't already have all these parts stolen, which I do not. So we'll have to get Open Board View back up and running and see what that component was. So that component is C6990. It is a 10 microfarad 25 volt capacitor. I'll just check this one that I stole the resistor from. And what size is it? It's a 0805 size. So Let's do this together. 10 UF. It's only 16 volt. Here we go. There's one that's C9712. So let's see where that is. So that's going to be, let's grab the other board. Confused. Where is this? Okay, it's that one right there. Okay, so we're going to go ahead and steal this from yet another board since I accidentally dropped the first one. Oh wait, actually I see it right here. Look at that. You even have the exact right size now. So now, wait, sorry I forgot to switch you guys back over. There we go. Okay, so we got it soldered on. A little bit of flux, and then I'll reflow it back into place so it looks nice. No, don't you run away from me. There we go. That is beautiful. So now let's check to make sure it's soldered properly, which it looks like it is. So now we'll go ahead and verify that the short is gone. And the short is indeed gone now. So just real quick, before I go ahead and test this out again so I don't have anything catch on fire, I'm going to verify that PP3V42 is not shorted to ground. So that's ground, and this side is not shorted. I'm going to go ahead and let my hot air turn off. This time I'm, just in case it catches on fire again, I'm just going to flip the power off to the adapter, but I have some other things plugged into that switch too. So if the light goes off, it's probably because something started burning. But hopefully we'll be lucky this time and nothing will burn. So I'm just going to go ahead and start this with the power off. See, we got no light. And I'll plug this in to the DCM board and I'll turn it on, and hopefully we don't get a fire. But I'm going to move my microscope just in case. Hey, we get no fire. But you know what we do get? I don't know if you can see that, is we get a light on the charger. Which means that this board is more than likely fixed. I'll still have to put it back in the computer and thoroughly test it out, but we should be good to go for now. So I hope you guys enjoyed this stream, and hopefully I'll have a few more that I can do coming up in the future. So bye for now.